Hey there, it's Mr. Broderick with another 5-minute review lesson of North Carolina EOC standards. Right now we're going to look at Goal 5.01c, which deals with population growth and carrying capacity. Before we begin, let me remind you, population is a group of organisms of the same species living in an area, like squirrels, humans, etc., insects, go on, plants. And there's a couple things that define population growth or kind of underscore, right? So we talked about them before we begin. First off, populations always want to grow. So populations want to grow. And by that I mean they will have lots of babies if they can. Right. The second part about that is that that populations need resources to grow. So populations need resources. So they need food, they need shelter, they need water, things that they get from their environment. So they need abiotic and biotic factors, really. Also, but there's one thing that's kind of also coming from the environment, and that is that environments, habitats, have limited resources. So that means that in a forest, squirrels need nuts, but there are only so many trees. Or plants need light, but there's only so much sunlight because other plants block them out. Humans need food, but there's only so much food. Well, not nowadays. We got McDonald's right around the corner, but you get the idea. All right, and so what this looks like in terms of population growth is, like, let's say we have squirrels which move into a new environment, and I love using squirrels. So here's the population on this axis, pop. Okay, and the population increases on this axis, and here's time. And the squirrels populate this new environment, and they find lots and lots and lots of food, and their population just starts to grow exponentially. Right? Kind of looks like a x squared graph or something to the x graph, and that's called exponential growth. And they will grow like that until they reach some kind of limiting resource. Again, limited resources. So those squirrels might not have enough nuts, and all of a sudden they're having too many babies for the amount of nuts and food available, and they reach this plateau. And they might do a little dip back down because they overshot, right? They made too many squirrels, and all of a sudden squirrels die off a little bit, and then kind of regain control, and you get this wavy effect where they're going up and down but staying pretty much at a balanced level. Okay, this is when they become in balance with their environment, the resources in their environment, and that squirrel population has reached some kind of level that it will stay at. Okay, and this population level might be 20,000 in an area. That level right here that they reach is called the carrying capacity. It is the capacity of the environment to support the squirrels. And the capacity can only support 20,000 squirrels in this example. So their beginning of their growth was exponential right here. But when they reach a limiting resource, the amount of food, water, sunlight if you're a plant population, then you're going to reach a carrying capacity where the environment can no longer supply enough food or energy or whatever they need to continue their growth. All right? So that's carrying capacity in exponential graphs. What you'll see sometimes, if I kind of shift this over, on the EOC, they'll look at populations of bacteria. Now bacteria, population on this side, pop, and time again on this axis. And populations of bacteria over time tend to do this. Because bacteria are so small, their growth is exponential over periods of times, usually. Now, this is not true. They can still reach a carrying capacity and level off if they reach maybe a size carrying capacity. They can't grow anymore because the dish they're growing on, or the human hand they're growing on, isn't big enough to support anymore. There might be enough nutrients, but there's just a size limit. So bacteria tend to grow exponentially, and this sometimes shows up on the EOC. So don't get confused. It's still exponential growth. It just hasn't reached carrying capacity yet, so it's still free of its limiting factors. So these bacteria might not have any limiting factors right away, whereas when we're dealing with bigger organisms, they reach their limiting factors quicker. They need more energy, they need more food. Bacteria are small, they don't need large amounts of it. They can grow in lots of places, as you know, because they're all over the place. That's why you use antibacterials. So this is just a basic overview of population growth. Reread this, listen to this again if you need to, but this should have everything on there that you need to understand this part of the EOC.